name is Jisoo Kim and I will research about crystals. Because I am curious about it because I didn't learn about it enough before. Go through this research, I learned about information of crystals. And now I will introduce you about it. First, I will talk about basic information of crystals. Crystals are materials that are surrounded by flat plates. Every particle that consists of particles are arranged regularly like this picture. On this picture, circles are particles and they form the picture regularly. And there are more information about crystals. Crystals' internal structures are regular so the melting point is consistent and crystals have symmetry. Look at this picture. This is solid liquid vapor phase diagram. This is influenced by temperature and the pressure. And this is the melting point. And crystals have isotropy and materials that are not crystals have anisotropy. And this is the last part of information of crystals. Crystals are commonly recognized by their shape consisting of flat faces with sharp angles. This, like on the purple one, they have sharp angles on here, and the blue one have flat faces on there. And these shape characteristics are not necessary for a crystal, but those characteristics microscopic shape is often present and easy to see. And now I will talk about the difference between solid and crystals. First, particles of solids have a regular form, but particles of crystals have regular form. And solids' appearances are regular, but crystals' appearances are regular. And there are no particular physical characteristics like melting point on solid, but crystals have physical characteristics like melting point. And next I will talk about isotropy and anisotropy. I mentioned this before, but this is quite hard, so I will talk about this more. Anisotropy is used to describe situations where properties vary systemically dependent on directions. And alternatively, when the properties of material are the same in all directions, the material is said to be isotropic. And anisotropy is opposite to isotropy. Anisotropy implies identical properties in all directions. When the properties of a material vary with different crystallographic orientations, the material is said to have anisotropy. And these are examples of crystals. I'm sure that you know first one and the second one. As you know, first one is the crystal of salt, and the second one is ice. And I think you don't know third one and the last one because they are not common. Third one is quartz and the last one is bismuth. And there are more examples of crystals. The first one is snow, and the second one is naphthalene, and the third one is copper sulfate, and the last one is argon. Have you ever made crystals or think about how to make crystals? They are quite easy. And I will talk about how to make crystals of salt. First, tie a big salt with strings. Second, make very strong salty water. Third, put number 1 into number 2's middle, and wait and it will appear and go like that picture. And this is more harder, but it is quite easy to first make a shape with wire the crystals will grow. Second, cover number 1 with glue and melt much of copper sulfate as you can. and put number 2 into number 3 and wait for a long time, and it will appear and grow like that picture, the blue quadrangle. And this is the last one. First, put naphthalene in a beaker. Second, put the first beaker in a bigger beaker and warm up in a double boiler. Third, if the water is warm enough, put on a round flask with cold water, and there will appear some crystals of naphthalene. You have to remember that naphthalene is a combustible substance. If not, you can get some burn injuries. And these are sources of information. And thank you for listening.